Pantech e-learning welcome you all. So today we are going to see about big data analytics solution, and let's check the audio and we'll move on to webinar. Pantech e-learning welcome you all. Yes, it's perfect. Okay. So okay, so the respected college Sri Chandrasekhar Andhra Saraswati Viswa Magavidyalaya. The college is today conducting the webinar on big data analytics solution, and then by Department of Computer Science and Engineering of that respected college. And good evening all. So I am Kamlesh, I am from Pantech e-learning. So today we are going to see about the title of big data and how we can analytic with the big data. Okay, so this is all about today's webinar topic, and we have some other I like to tell about our Pantech solution. And the main aim of Pantech solution is like RN research and development industries projects and faculty development programs and hands-on training workshops, internships and in-plant training, short-term courses, value-added courses, academic project training, and then customized design service and state also. And we have started from origin from 2004 and 7 branches. Now we have 100 plus employees and 1200 plus workshops we conducted, and still it's going on through online and medium also. So if you are willing to join with us, we at last I will tell you about internships and then workshops of upcoming days. So please note it out, and then you can contact our faculties, that is our managers, they will help you. And this is all about Pantech. And then we are giving another also projects also for EC and EEE department and CS and IT department. So EC and EEE department means we have Internet of Things, artificial intelligence and embedded system, robotics, VLSI, FPGA and TMS processors, image processing, network simulation, power electronics and e-vehicles. And then we have another hand we have CSE and IT domains. This is all about big data and data analytics and then Internet of Things and Python, Android, Kotlin development, and then data mining, text mining, machine learning, deep learning, and then cloud computing and mobile computing. Okay, so this is all about CSE and IT domains. So we are not only with research and development, we are having branches in academic projects also. And this is the table of contents of today's webinar. We are covering, like, first of all we are covering the introduction, what is the big data and what are the big data problems and all. And then next we are going to checking what is Apache Spark. Okay, so going to see about what is Apache Spark. Why? Because it's one of the technology used for big data analytics. So we are going to see about Apache Spark, and then introduction to Spark, and then applications of libraries of the Spark, and then what is data science. Because if you are taking any domain, definitely you will be have an data science. It's a common. So about data science, how it's working on Apache Spark, and then platform of the Apache Spark, that is interfacing the platform, and applications and how we can set up the Apache Spark. So we are covering those details, so don't forget to watch. And then introduction to big data problem. So first of all, we need to know about big data. So we already know about big data problem. We already know big data, right? So big data means we have a large amount of data collecting through each and every day through online medium or any social media or any other bank scatter or any other like medical related things. Okay, so that is big data. So big data is we have large amount of data. Okay, so how we can compute those large amount of data? Okay, for example, if you are taking our mobile phone or our PC, we got less amount of data. So for running those, seeing those and manipulating those data and editing those data, we can easily do. Okay, so we can usually do with different type of OSs and we can do it with that one. But if we have a large amount of data, we need some different platform. Okay, so we need to access, we need to do some activities with a different platform. Okay, so that's why we need some platform for big data analytics. So that is the platform we are using now currently, Apache Spark. So that's why we are going to see about what is Apache Spark, but we will move on to Apache Spark. Apart from that, we will just give an introduction to big data and then we will see the problems of big data, then we enter into the Apache Spark. Okay, so big data is nothing but it's like, what is big data means, we need to tell GB or TB or PB or EB. Okay, so it's nothing but it's data, gigabyte, terabyte or petabyte or exabyte or zettabyte. Okay, so that is big data, right? Then why we are using big data? So we are about social sites, we have social mediums, and we have a web search engines, and we have web technologies, and we have some web applications and all, right? So we need to process those things, means definitely they will have some data. That is, data will be in the form of structured or unstructured. Okay, so structure means nothing but the data with a clear manner. Okay, so we can understandable. Unstructured data means it's not in clear manner, we need to convert into the structured type. Okay, so that is why we are using big data. And then how we are using a big data? So we need to do some process with big data, like storing the data from somewhere or processing the data from somewhere. Okay, for that purpose and all, we are using some Hadoop or Spark type of technology to accessing and manipulating the big data. So let me see next slide. So next slide is all about 3 V's. Okay, so now generally they will call us a 3 V's. 3 V's is nothing but it's a volume, velocity and variety. Okay, so volume is an amount and quantity of data, and velocity is nothing but speed of data, and then variety is nothing but type of data to be stored or processed. Okay, so this is all about volume and velocity and variety. Okay, so next one, the big data problems. So what are the problems if you are doing with big data? Means the problem is, first one, power of computers, application and hardware grow within time. Okay, what is the problem with that? Means each and every day we are upgrading into new technology, right? New technology. For example, if you take an Android mobile phone, we are having upgraded, or we are using some different type of applications. So using those applications, we are updating each and every day, like same thing only. So we are technologies related and hardware related, we are changing each and every day. So first we have a rear fingerprint. Now we have a in-display fingerprint. So like that we are changing into technology wise and hardware wise also. So like that, if we change means the data also will be huge, right? So each year we are implementing a new processors and new things and applications to run the topmost applications for the fast manner. Okay, so that and all we need big problem. Okay, so for that problems we are using like some other softwares. Okay, so there is so much data available in our process. We are analyze, we need to compute those data within seconds or within hour. Okay, so for that purpose we are using the Apache Spark. Okay, so what is Apache Spark? Apache Spark is nothing but it's a unified computing engine. Okay, so it's a unified computing engine. We have a set of library files in that unified computing engine, and using those engine we will process the cluster of computers. Okay, so we will process the cluster of computer. For example, yesterday we taken blockchain technology in our YouTube channel only. So that blockchain technology we use like decentralized network, like same thing only we are doing here also. Okay, so we are combining the different type of PCs, okay, with the cluster, that is cluster of computers. Parallelly we can process those cluster of computers, that is Apache Spark. Okay, so Spark is a big data solution that can be proven to be an easier and faster than Hadoop MapReducing. Okay, so Hadoop MapReducing, so if you are seeing Apache Spark nowadays, means before it came we are using an Hadoop MapReducing technology only to process the cluster of using the cluster of computer we are processing the data. Now we are entering into the Apache Spark. Okay, so this is the basic difference between Apache Spark and Hadoop. Here we have an presentation about how it's working. So improve the efficiency through, okay, so memory data sharing and then general computing graph. It is 100 times faster than the previous software, that is Apache Hadoop processor. Okay, so it's a fastest one, and then it is usability through rich APIs in Java and Scala and then Python. Okay, so we have 2 or 5 less than code we will use in this Apache Spark. Okay, the next one, what are the platform we can use using Apache Spark? So we have, for example, if you take a Python language, means we will use like web application or desktop application. We can use machine learning, we can use deep learning, and like that we have some domains, right? So like that also we have a score that we using Apache Spark. So one is you can use SQL structured data, we can spark the SQL structured data, and then we have Spark streaming real time. So Spark streaming in real time, we can stream the data, and ML libraries, that is machine learning libraries, and then we can plotting the graph using GraphX libraries. Okay, so this is the way we can do this process. And then this is the ecosystem of our big Apache Spark. So in storage wise you have like this, storage wise you have local FS, HDFS, Amazon, and then RDBMS and NoSQL. Okay, so in storage wise we have options like this: local FS, HDFS, Amazon FS, RDMS, like that. And in management wise we have totally only 3 only, like how you, if we pass some data, means we need to save those data using this type of management softwares only. Okay, so we have Spark, Yarn, and then Mesos, and then engine. So engine only one, we have Spark core engine, and then we have a different type of libraries, right? For example, if you take an Python language, we have different type of libraries like Pandas, NumPy, Matplotlib, or Seaborn, or Keras, TensorFlow, like that. Like that we have different type of libraries for Apache Spark core also, so like SQL and then ML library and all. And then we have a programming. Okay, so like Scala we have. Okay, so one of the most used program for Apache Spark, and then Java also we can use Apache Spark, and then Python, even Python also we can use, and then R programming language. Okay, so this is what we are using. This is the ecosystem of our Apache Spark. And then here we have a commits in past year, and then coding change. So about large community, about code wise. Okay, so here we have a code wise compared to any other Yarn or HDFS. Then introduction to Spark. So let's we enter into the Spark. What is the Spark and why we are using and all we will tell. So the main using Spark, it is if you have a complex task, okay, you can quickly do with multiple pass analytics. If you have an interactive also, it will be easy, and then real-time stream processing also it will be easy. Okay, we can share the data, we can stream the data. Okay, so that is what we are using this one. And then you need to know about map reducing technology. Why? Because it's a previously before Apache Spark we are using Hadoop map reducing technology only. Okay, so first we will see about map reducing technology, how it's working, then we will see now what technology we are using for Apache Spark. Okay, so first of all, map reducing technology using Hadoop. So here you can see data sharing in MapReduce. So for example, if I have an input data like this, welcome to Hadoop class, Hadoop is the good, Hadoop is the bad. So we have a one text file. So what I am doing, this text file means I am converting my text file into input split. Okay, so here I am taking the input of welcome to Hadoop and then class Hadoop is, and that is each line I am taking and one different split data. After I am doing this one, I am mapping. So that is called map. So because we are using a map reducing technology, so I am mapping the each words. So mapping each word means nothing but here welcome to Hadoop. So welcome only one time repeating in first box, and then two only repeated only for this in this one, and the Hadoop also repeated for only one time. So like that I am counting each and every word how much time it's repeating. Then I am adding into the mapping column. So after into the mapping column, I am shuffling the column. How I am shuffling means based upon the word wise. Okay, for example, if I have a Hadoop word here and here and here, right? So I will add that Hadoop word into the single box. Then any other technology will be added into, any other words will be added into some other shuffling box. So that's what we are doing here in shuffling column. Then reducing. So mapping we done. Now we need to reduce. So using reducer I am reducing. What I am reducing is here the repeated words. Okay, how many times repeated words is there? I am just counting the words. Overall words will be counting and save it in one final output. That is here Hadoop is repeated for 3 times. So I am taking it as a Hadoop comma 3, then save it in output final output. So this is called map reducing. So this one is for text type. For example, if you take it an image also. Okay, so for example, user A will send the image a.jpg. Okay, and then user B also send the same image but some other sources like a.jpg. Okay, so both are same image only but sent by different user. So based upon this also we can do map reducing. Okay, so that is called map reducing. And here the data sharing of in our Apache Spark. Okay, so if you have a data, here I am taking a list of data. Okay, from 1 to 99. So here I am taking some RDD. That is RDD is nothing but I am taking some random data from 1 to saving my random data into 1 to 9. So you separate RDD, and then here I am having a worker and master. Okay, worker is nothing but worker will be physically it will be do some activities with this RDD, then it will be saved in master. So it's a simple way. We don't need to do some other different type of map reducing process and all. We can save it our data. You can using this RDD sharing itself, we can save easily. Okay, so that's why we can 10 times faster than the other, that is Hadoop. Apache Spark is 10 times faster than the any other technology. Okay, so even we don't need to iterate n number of times, right? So that is what we are doing here. And then Spark model. So we have that is RDD is nothing but it's called as a resilient distributed data set. So the data set consists of some object stored in the memory disk. So using those, that is, it will be across the cluster. Okay, so based on that we will transform the data, and then automatically it will be rebuilt. So for example, if I sharing the data from one place to another place, if anything problem with sharing, it will be automatically rebuild the failure. Why? Because we are using RDD method. So RDD method means we have an already copy of that data in somewhere. So using metadata only we will copy the things. Okay, so that is Spark model. So here you can see example for log mining. So log mining and log analysis. So we have collecting the log data and cleaning the log data, converting into the structured form. That is, if you are collecting the log data, it will be in unstructured manner only. We need to convert into the structured manner, then analyzing the data. Okay, so we will get a result. So this is the log mining data, and then fault tolerance. So fault tolerance also compared to any other map reducing technique in RDD, we have less number of fault tolerance only. So using Apache Spark, and then here we can see the building of logistic regression. Okay, so logistic regression is one of the machine learning algorithm. So using machine learning algorithm, if I am training the data set both with Hadoop and Spark technology. Okay, so I am training I'm taking a general data, so any data I am training those data for both Hadoop and Spark. So we have a x-axis number of iterations and y-axis running time. So for example, first iteration we have a blue color as a Hadoop and orange color as a Spark. For first iteration I am getting Hadoop as the first and then Spark as a second. Okay, so it's something here high compared to Spark, right? But in fifth iteration we are getting a double of that Hadoop compared to Spark. Okay, so in 10th iteration I am getting an even more high and even more high Hadoop. But you can see the iteration of Spark, we are having only same iteration result only. Okay, that is what the compared to map reducing technology of Hadoop is easy with Spark. Okay, so logistic regression will be easily give the result using Spark technology compared to Hadoop. Okay, and then here disk performance of Hadoop for time sort by 100 TB. Okay, so for 100 TB it's time shortening. Here you can see if I run with Hadoop, we are getting 72 minutes for 2100 machines. Okay, but in 2014 record for Spark for 207 machine itself, I am computing this 100 TB within 23 minutes. Okay, so to computing this 100 TB, I am taking a 72 minutes in Hadoop technology, but I am getting only 23 in Spark technology. Okay, so this is the disk performance of Hadoop and Spark. And then supported operators, because operator is important. Whatever language we are using, operator is the one of the main key will play the role operators. So here we have some operators like filter and group by union and then fold, count, reduce. So these are some of the operators in Spark. And then user community. Okay, so user community is nothing but whoever will give Spark community. Okay, so here you can see different type of YAG is there, EBay is there, IBM is there. But if you want to run real time, okay, so if you want to see the Hadoop usage and you want to do some other cluster based network connection, means we have freely available with the Databricks. Okay, so it's it's a limited access only, but you can use Databricks. It's easy to implement. I will show you how we will open that Apache Spark using Databricks website. I will show you at last. You can check it out how we can do Apache Spark. Okay, then application and libraries of Apache Spark. So we have applications like Python, Scala and Java, so we already know. And we have SQL task, and SQL task means we can save it as a SQL related queries also. And then we have stream the data that for real time live streamings and all, it will be useful. And single mission, using run the single machine or cluster of the computer. Okay, so we can, it will be supported for only one machine also, and cluster of computer also, and machine learning, deep learning also we can do with Apache Spark. Okay, so here libraries available, this one we already seen, right? So we don't, next one we will see in depth of other libraries. Okay, so here we have an totally two type of file, one for JSON file, another one for Hive, and we can read easily using those files. Okay, so it's like just here I am mentioning how we can read our data set using Spark SQL. And then here we have Spark streaming. Okay, so Spark streaming is to stream the data, how we can stream for Twitter. Okay, so if I using a lambda function, so it's a inbuilt function, using lambda function I am passing the windows for how many seconds each and every time I need to pass the window, here I am giving, then it will be automatically stream the into the Twitter system. And then ML libraries. Okay, so we can use like this, like using k-means algorithm, you can easily import the k-means algorithm and train the data. So train the data means we need to train the data algorithm. So passing my data, the data is nothing but points and then 10. So point is nothing but the data which I am reading using a text type, and I am reading using that, I am checking for point, and we can predict the new point also. Okay, so I already trained that some points with the class. Now if we enter the new points, we can predict the output using ML library. So it's not just you see the language. Okay, so you can see how we can do with this Apache Spark. Okay, then GraphX. So GraphX in name itself we have a suggest, we can plot a graph like bar graph or line graph, any type of graph using your product data. Okay, so this here for machine learning, for streaming, okay, for Spark SQL, the data which we are using, it's not a normal data. Okay, so it's a big data. Okay, so for big data purpose I am telling now, so don't think about normal data. So like if you are going with UCA website or Kaggle website or any other Google dataset.com also, we have only like CSV file or picture file, few data is all about like few MBs only, okay, megabyte only. But here okay, so GraphX, so performance and specialized of engine of for SQL and streaming and machine learning. Okay, so here you can see here response time. So y-axis will be response time, don't confuse. For response time in SQL compared to any other like Hive or this one, the Impala disk, and then here I am getting a Spark disk is something good. Okay, and then here we have a throughput time. So streaming purpose we have a Spark will be high when compared to Storm, and then machine learning response time is good compared to any other like this packages. Okay, so for machine learning and deep learning and streaming technology. And then combining process also we can do. Okay, so combining process is nothing but we can add some other advanced packages also. For example, here you can see I am using here k-means, right? If I need to using this k-means, I first of all I want to train the algorithm. After training the algorithm, I want to predict an output. After predict an output, so like that for training, for reading the data set, and for training the data set, and then for testing the data set, I need to write the code line by line only, right? So it's difficult. So I am writing the code line by line. It's difficult, right? So we can combine all the process from dataset reading to predicting the output. All the code also we can combine using the method of like what is that method? Pipeline method. Okay, so about pipeline method we will discuss in next slide. Before that we will see the combining process types. Okay, so here you can see we can combine the process of HDA bus with HDA bus like train. So this is the combining process, but we will see the about pipeline. Okay, so here you can see we are combining all the process with Spark. So here we are combining only separate engines and applying, but here we are combining all the engines with single line. So that is the use of Spark and Python and Scala. So we can done using that one. So normally they will call us, this combining process will be called as the pipeline technique. Okay, so pipeline technique is nothing but combining multiple process into a single function. Okay, so that is pipeline technique. And then next one, data science. So data science, here we have a data science. So first we will see the data science and we will see the platform interface. Okay, so first we will see about data science. So data science is nothing but it's a important one, right? So we based upon the data science only we will understand the problems and we will understand the data set attributes and we will understand what type of algorithm we need to use and what type of machine learning type is that. Okay, so which type of algorithm we need to use, whether it's a classification or whether it's a regression, like that we need to analyze. Means we need some technique that is called data science. Okay, so using data science only we need to do some statistical information and so. Okay, so here you can see data frame. So data frame is nothing but we have data set with your data set in the form of structured manner with n number of rows and columns. Okay, so here you can see frame from 2007 to 2016. Okay, for R language and Python language. Okay, so data frame nowadays we are using n number of times comparatively. We have JSON file as a data set, or we have a CSV file as a data set, we have text file as a data set. So using those data set we can convert it to a structured manner and we can train the algorithm and test the algorithm. Okay, so here Spark data frame also working mostly in Python only. And then machine learning pipeline. So we already discussed about pipeline, but here you can see actually I am writing the code totally. This is the first line of code, this is the second line of code, and this is the third line of code. Okay, so first line of code is tokenizing. Tokenizing is nothing but we are converting our paragraph into a single words. Okay, so that is called tokenizing. And TF is nothing but we are converting our text in readable, so that is DF. And then logistic regression algorithm, so regression based algorithm. So lines of code. Okay, so if I want to do some process, means we need to finish those steps. Okay, and training the model. But if I using pipeline technique, means we will do it with single line itself. So just we need to combine all the function into the single function, then we will train the algorithm. So that is the use of machine learning pipeline technique. Okay, so this is the pipelining technique. And then we have R interfaces also. So R is the programming language used mainly for data science purpose. So we have R interface also. And then let me enter into the performance interface. First of all, we see about the platform here we see in the data science interface, data science. Now we enter into the platform interface. Okay, so what are the platform we can do with this one? Okay, so platform interface, here you can see we can use as a API of Cassandra or Apache Habas, okay, or PostgreSQL or JSON, MySQL, Elasticsearch. Okay, so Elasticsearch means DevOps. Okay, so for those APIs and all we are using this one. Okay, so we can use this type of plugin smart data source into the Spark and then we can easily use. Okay, so not generally, if you want to know, means in machine learning or deep learning we are using some packages like Keras and TensorFlow or Scikit-learn. Okay, so like this API we can use it here also. Okay, And the API connectivity also is easy only. For example, if you want to use a MySQL API, you can easily run with like this from MySQL user, and you can import you can join the interfaces. Okay, so that is the data source API interfaces. Plugin will be a smart, and then data from usable also will be a smart. Okay, so that's what. And then current data source, here you can see we have a data source of built-in HIV, JSON. These are the data set we can available in built-in, but in community level we have like CSV, comma separated value, and Avro, Elasticsearch. Okay, so you can use those things also. You can run it with your PC, but built-in is this one only, JSON face and all. We can read it. But if you want to read those things, you need the package of respected to read those data set. Okay. Then how we can learn more about Apache Spark? So you can download the document from here. So Apache Spark organization, and then you can try the Databricks. Okay. So Databricks, I already told you how. We can, if you want to try the Apache Spark, you can use this website, and you can build your own Apache Spark application. Okay, so let we see how we can build our Apache Spark application, own Apache Spark application and partitions. Okay, so first of all, here you can see we have an driver, processor, and executor, and cluster manager. Okay, so cluster manager means always if you are giving any task, if you are giving any task, okay, you will assign those tasks to the executor. Okay, so assign those tasks to the executor. So executor will be compute those tasks and give it to the cluster manager, and then cluster manager will be give it to the output processor. Okay, so this is the basic running procedure of PySpark application. Okay, so here driver is nothing but driver is located in the node of cluster. So this is the driver. So driver will be compute three main tasks. One is hold information. Okay, so hold the information and respond to the input. Okay, so driver will be computed three main tasks: hold the information, respond the input, and analyze the distributor and schedule. That is, we are now working on Spark community, right? So Spark have different type of cluster of computers will be there. Okay, so for if you want to handle those computers, we need this driver. Okay, so driver will be used to compute, distribute, and schedule the cluster of computer to do some work or task. Then after that, executors. Executor is nothing but it actually perform the work. That is, if I join with the Spark community, I am one cluster. I am one of the computer, right? I am the one of the person in that cluster, right? So for my PC also, the driver will be allowed some work or task. So we need to do those things. Means we need act as a executor. Okay, then after that we need to cluster manager. So cluster manager is controlling physically about computers. Okay, so how the several application will be running, what is the any problem is there, or what is the thing we need to do for those computer. So that is the thing of cluster manager. Okay, so this is the three important thing about Apache Spark architecture. Okay, then how to set up then Apache Spark. So we already we now seen all the things, how it's working, and which are the way we can work our Apache Spark, and why we are using Apache Spark, and what is the difference between MapReduce older technology of Hadoop and now trending technology of Apache Spark, and what is big data problem also, everything we seen, right? Now we are going to set up one Apache Spark. Okay, so here we already have an setup instruction. Okay, and a screenshot I am having, just you can see it. So one of the simplest and fastest way to work on PySpark, you can use Databricks.com website. So Databricks website will be give the free community edition. Using that community edition, you can build your own Spark, and you can run both locally and cluster of computer. Here it's a highlighted point, you can run both locally and cluster of computers. Okay, so if you want to do with cluster of computer of work also, you can do. Okay, so that is one of the important. So here we have a website. So here https databricks.com. Try data. The link after this webinar in our description, you can check it out. So using this link we can, otherwise you just search it in our Google search databricks.com. there you will be have a try option. So sorry, after you searching this, you will website screen, so you will be have a option like get started or get started. Two get one is for free trial and then next one is for community edition. So this one also free only. Okay, but community edition will be, we can cluster, we can join with the cluster of computer, but maximum 3 user only. Okay, so that one is important. Here you can, if you click this community edition as a get start, then you will be enter into this welcome page. But before that you need to do some registration process. Okay, so about your mail ID or about your name and why you are using this Databricks and what is the occupation, whether you are using for educational purpose or your company purpose, like that you need to give some details. After you giving those details, you will be entered into this databricks.com. then you will have here option like create a new notebook or create a table or create a new cluster. You can add your friends also using this cluster, but minimum 3 only. You can add with new clusters, and then like that we have, if you want to import your own data, you can drag and drop your own data. So if you want to create a new blank notebook, okay, so you can create like this. Okay, so after login you can do with basic operations like PySpark, basic operations with PySpark like data pre-processing or build data processing using pipeline, and build the classifier, train data and evaluate the model. Okay, so these are the steps we can basically do for machine learning purpose. But if you want to do for streaming purpose or graphical analysis purpose, we have different type of steps. Just here I am mentioning what is the steps for machine learning. Okay, so we can do the work. So please try it with Databricks and then check it out the details. Okay, so this is what I need to tell you about how we can work with machine learning and machine learning with Spark. So if you have any doubt up to this, you may ask it in our comment box. I will help you about your questions. If you have any doubt regarding up to this, you may ask it in our comment box, and then I will tell you about okay, I hope only less amount of chat. Okay, I told you about internship, and internship is all about IETV, that is the Institution of Electronic and Telecommunication Engineer. Okay, so if you will get with this, and the IET internships will be started, technical training program will be started on 3rd August itself. We have 5 days internship for its amount is only 300 and 350, so please check it out. And then we have internships on 15 days. The 15 days is all about 3 weeks. Okay, so each weeks we will compute the different type of domain technologies. So if you, that is fully hands-on training only. Okay, so there is no just theoretical sessions, so fully hands-on training only. So if you need about the even more detail you need, you can contact the persons. So this is the fees is 1600 per student if you are IIT member. If you are non-IIT member, the 1750 per student. Okay, and we have a week 5, so it's the last one, week 5 we have, and that is tomorrow and day after tomorrow. So the week 5 is all about Microsoft Azure protocol and approach the computer vision. Okay, so this is a national level online workshop. So if you wanna join, you can join for these 2 days. The session will be 2 hours per day. Each day it will be 2 hours, and then amount is 300. Okay, so if you are willing to join, you can contact those persons, Mr. Sendil Kumar, Mr. Srinivasan, and Mr. Kumarasamy. Okay, so the next one is thank you all. If you need any furthermore upcoming event details or furthermore information, you can contact us on WhatsApp and Telegram also. Okay, so thank you all, and I hope everybody will understood about big data